Hello, good morning, ma'am.
Yeah, very good morning.
Good morning, ma'am.
And we are waiting for some of the presenters, and then we will start the meeting in about 5 minutes.
Okay, not an issue.
Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 7B. Myself, Ashutosh Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17 to 19 July 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for the session, Dr. Disha S. Wankhede. Dr. Disha S. Wankhede is currently an assistant professor at Vishwakarma Institute of Technology, Pune, India. She has 16 years of teaching experience. Her skills and expertise lies in machine learning, computer vision, and artificial intelligence. Her research area includes deep learning and image processing in healthcare and agriculture domain. I would now like to invite Dr. Disha Swankade to share a few words of encouragement with our attendees as we begin the session.
Yeah. Good morning, all. Thank you for this opportunity. And definitely, in today's session, we will listen some good insights from the participants and expecting that some good research-oriented things. And thank you. Yeah, please start. Am I audible? Hello.
Yes, ma'am, you're audible. So start without further ado, let's start with the session. Starting with the first, starting with the first presentation. I would like to call upon Sir Mustafa to present this paper on the title AI-driven disaster prediction, integrating earthquake and flood forecasting for enhanced resilience. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Sir NSSS Aditya to present his paper on the title Developing a CNN Model for Effective Lung Cancer Classification on Histopathology Images. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Ma'am Sneha S. Biradar to present her paper on the title Effect of Music Therapy on Children Suffering with Neurological Disorder. Do we have you here with us, ma'am?
Yeah. Shall I share my screen?
Yes, just a second. You can share your screen.
Okay. Is the screen visible?
Yes, ma'am, your screen is visible.
Good morning, everyone. I'm Sneha Biradar from KLE Technological University, and I'm here to present our work titled Effect of Music Therapy on Children Suffering with Neurological Disorder. This research explores the integration of machine learning and music therapy to provide a personalized therapeutic approach for children with autism spectrum disorder, or commonly known as ASD. Here's the outline of my presentation. I'll begin with an introduction to the problem, walk you through the literature background, problem statement, objectives, and our proposed system. Then we'll dive into the methodology covering a data preprocessing, visualization, and ML model usage and severity classification. Finally, I'll present our results, conclusion, and future directions. Autism spectrum disorder is a complex neurological condition that affects the communication, behavior, and sensory processing. Many children with ASD struggle with emotional regulation and social interaction. While music therapy has shown a promise on a non invasive intervention, we aim to take it a step further by tailoring therapeutic music to individual severity levels using a machine learning. We reviewed several key studies. One used a ML model for early ASD detection. Another focused on a high accuracy classification through AI techniques. Third, evaluated the effectiveness of a music therapy in improving a social behavior in the ASD individuals. But we identified a key research gap. None of the studies integrated a real-time severity classification with the automated music generation. This gap inspired our hybrid system. Problem statement. ASD affects the emotional and sensory processing. Traditional therapy lacks personalization. Our goal was to create a system that identifies severity using a ML and generate personalized Mozart-inspired music based on that classification. Objective. Our objectives were to develop an automated system that classifies ASD severity, to generate personalized instrumental music based on that severity, to promote emotional regulation and a cognitive improvement using a tailored musical stimuli. Here's the proposed architecture. It involves data collection and preprocessing, ML-based classification, severity calculation, and music generation using Pretty. Each children receives a music tailored to their classification. Data preprocessing and feature selection. Here, we checked for a missing values, found 0% missing values, ensuring a complete data set. Removed unnecessary columns, for example, case number, and reordered a feature for a better processing. Data visualization. Here we can see the bar graph, which shows age in the months and the count of them. And most of the toddlers are around like 36 months. And here's the representation of a Q10 chart score, where each of this represents the scores, and more majority scores falls in between 2 to 8, indicating ASD traits variations. This is the impact of a jaundice and a gender. Male and a children with a jaundice showed a slightly higher ASD trait scores. We applied a 5 machine learning models to predict ASD traits. SVM gave the highest accuracy of 97.5. Decision tree and a logistic regression both gave a 96.7. KNN scored 95.8. Random forest slightly lower at 93.3. SVM was chosen to a final classification due to its performance. Severity classification was based on a Q10 chart score and prediction weight behavioral attribute such as A1 to A10. We formulated like S is equal to summation of AI multiplied by WI, where AI is the answer in terms of 0 or 1, and WI is the predefined weight, based on which severity will be classified. And if the severity score falls in between 3 to 8, it's considered as a low severity. And if the score falls in between 9 to 12, it's considered as a moderate severity. If the score is greater than 12, it's considered as high severity. Once the severity was identified, we used Pretty MIDI, a Python-based MIDI manipulation library, to generate a music. For a low severity, 15-minute calming music with a simple harmony. Moderate severity, 30 minutes of balanced complexity. For high severity, 60-minute rich dynamic music to stimulate the sensory responses. As you can see it from the image, that for the low severity, there are less variations, and for the moderate severity, there are moderate variations in the music generated. For the high severity, there are pretty much high variations in the music generation. To make the system more accessible, I also developed a user-friendly web interface, which shows results in terms of the moderate uh, severity classifications, and also the severity analysis in terms of sensory and eye contacts and many more attributes. These are the 10 questions based on which a severity classification will be done. To summarize, we developed a hybrid system combining a rule-based logic and ML for ASD classification, generated a personalized music therapy using Pretty. These are the references for our research, and thank you, everyone.
Okay, very good, Sneha. I have one question. As your topic is very good, actually, it's need in the recent years. Actually, I'm also working on the also.
Okay.
So only one question, that is the how you evaluate, means the progress evaluate in the children who is going for or undergoing this music therapy.
Ma'am, currently we need to work on that. Like basically, we need to children see the childrens how they react to the music generated. We are working on it currently. That
Oh,
okay.
okay, means it's not yet evaluation is done in the real world, right?
Yes, ma'am, it's going on. Yeah.
Okay, okay. Also, that is the basic question. That is, what key parameters you are considered here for this music therapy,
For the
like frequency or rhythm or a tempo, like things. What you have exactly key parameters considered?
ma'am, key parameters were based on the variations and the like
Music structure. I'm asking music structure actually.
tempo and everything. Basically, the whatever the instrumental things are required,
Mhm.
those key points has been considered.
Oh,
Yes, ma'am.
yeah. Continue your work. Very good. And it's a need actually.
Okay.
Very good. Yeah.
Thank you, ma'am. Thank you so much.
Thank you for your presentation, ma'am. Now moving on to our next presenter. Next, I would like to call upon Ma'am Ruby S. Chanda to present her paper on the title Enhancing Customer Experience with Generative AI-Based Net Promoter Score Prediction. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Sir Shiraj Patil to present his paper on the title Enhancing IoT-Based Fruit Picking with Reinforcement Learning, Transfer Learning, and Neuroevolution. Do we have you here with us, sir?
Yes, am I audible?
Yes, sir, you're audible.
Sure, I'll share my screen.
Sure, sir.
Is the screen visible?
Yes, sir, your screen is visible.
Okay. So, yes, good morning, everyone. My name is Sriraj Patil, and on behalf of my co-authors from Vishwakarma Institute of Information Technology, I'm honored to present our paper, number 439, that is titled Enhancing IoT-Based Fruit Picking with Reinforcement Learning, Transfer Learning, and Neuroevolution. Yeah, okay. So, as we all know, the demand for food is rising globally, yet the agriculture scene faces significant challenges like labor shortages. Uh, Automated solutions do exist, but the current robotic harvesters are often inefficient. They can damage the fruit and struggle to adapt to the constantly changing conditions of the real farm and constantly changing weather and environments. So our research addresses this gap. The goal was to create a smarter, more efficient fruit picking system. We did this by integrating three powerful AI techniques, that is reinforcement learning, transfer learning, and neuroevolution into a single cohesive IoT framework. Talking about our system architecture, Here you can see the system architecture of our proposed system. It consists of three main parts. Firstly, on the right, there is the IoT-based picker arm. This is the physical robot in the field equipped with sensors and actuators for the movement and a Wi-Fi module to stay connected. Second, in the center is the cloud server. This is the entire brain of our system. So it receives data from the arm, it stores it and runs our three AI models to make intelligent decisions based on the data it's receiving. And then the third is the user interface, which includes a mobile app and a dashboard. This allows a human operator to monitor the system's performances. And most importantly, there is a continuous feedback loop that runs. So the arm sends the data to the cloud, the AI models learn and adapt, and then the improved commands back to the arm. So this allows the system to get smarter over time. Okay, so methodology for reinforcement learning. The first AI that we used was RL or reinforcement learning. Its purpose was to teach the robotic arm the best way to pick a fruit through initial trial and error. We implemented a deep Q network or DQN. The model state includes the 3D coordinates of the arm and the target fruit. Its actions are like basic movement where the arm moves up, down, left, and right, and the arm gripper operations. We designed a reward function to guide its learning. The agent picks the large positive reward for a successful pick, a smaller reward for moving closer to the fruit, and it is penalized for making bad moves, colliding with obstacles, or damaging the fruit. The next methodology, transfer learning. A major challenge in agriculture is the lack of large labeled data set for every fruit, for every type of fruit. Transfer learning solves this. We took a powerful model, that is a ResNet 50, which was already pre-trained on a massive ImageNet dataset. Then we simply fine-tuned the final layers using a small dataset of just 500 images per fruit class. The result was remarkable. Our transfer learning model achieved 94.7 accuracy in identifying the fruits, which was far better than the initial 78% of a model that we tried to train from the scratch. This shows the power of leveraging pre-existing technology. And the third and final technique was neuroevolution. So its purpose is to evolve the arm's control strategies so it can adapt to dynamic, unpredictable conditions, like the changing in the lightning or the fruits being in a different position than in the usual. For example, a fruit is upright, that's a different position than the which it was trained on. We have used an algorithm called NEAT to evolve a population of 150 neural networks over 100 generations. Each network's fitness was evaluated based on its success rate, speed, energy consumption, and how little damage it caused. The networks that performed best were selected to reproduce, passing their traits to the next generation. After 100 generations, the evolved networks performed 37% better than the original rule-based system. Okay, so the performance evaluation. So this chart shows a comparison between the previous standard system, that is in red, and the enhanced system in blue. So you can see our integrated approach led to significant improvements across almost every category. We saw major gains in adaptability, efficiency, productivity, and fruit handling quality. This system is more autonomous and scalable. This demonstrates a powerful synergy between three AI techniques when they are combined. So in conclusion, our research successfully demonstrate that integrating reinforcement learning, transfer learning, and neuroevolution within an IoT framework can dramatically improve the speed, accuracy, and flexibility of robotic fruit picking. This work provides a clear pathway towards smarter and more sustainable agriculture, helping to reduce crop damage and our reliance on manual labor. While our results are currently based on simulation, the promising outcome lays a strong foundation for future work, which will focus on deploying and testing this system on physical hardware in real world farm environments. So before I finish, I want to acknowledge some of the foundational research that guided our project. These are all the references that we've used. And thank you.
Okay, Sriraj, I got your topic. I require that what exactly the data set you consider for this, or rather, where you have collected this data for this work?
Ma'am, it was a pre-trained from ImageNet. ResNet 50 comes with a ImageNet that is pre-trained models for fruits, and it is a small
So
data
you
set.
have collected from cattle. It's a freely available data set you have used here.
We have used the main part of this is the data set that it uses. It is far less than the one in traditional, for example, the traditional CNN uses. So with transfer learning, we simulate the images in different ways, and transfer learning helps in giving points to it on successful fruit picking. For example, if an image is different from the other, it recognizes it through transfer learning.
Okay.
Using small data set, we can just
Yes,
we can
that's
extend our
fine.
knowledge.
That is the small data set you have considered because you are applying this transfer learning. But the only the concern is if you are thinking that real time you have to deploy this model into the IoT or whatever the device is there. By
Yes.
device, is it ready?
We have run a simulation for it. We have yet to test it on the real world IoT.
Okay. So what impact of this particular design in this RL, reinforcement learning, on the picking efficiency? What type of impact will be there in this IoT-enabled robotics harvest?
The impact will be there will be less need of manual labor, for example, and also for reinforcement learning. While it is on small data set, it can pick with great efficiency, learning from its previous mistakes, and it will need less data set. It will be not trained on more data set. It will be more efficient than previous models.
Thank you for your presentation, sir. Now moving on to our next presenter. Next, I would like to call upon Sir K. Sai Karthikeyan to present his paper on the title Enhancing MRI Tumor Detection, a survey on image upscaling, GAN-based data augmentation, and federated learning in convolutional neural network. Do we have you here with us, sir? Do we have anyone else from the team with us?
So yeah, here.
Okay.
Yeah, hello.
Yeah, can we share our screen?
Yes, sir.
Yeah, thank you. Yeah, good morning, everyone. I hope my screen is visible. So today, I, along with my co-author, Jayant, are presenting on the topic called Enhancing MRI Tumor Detection. So this is a comprehensive overview of the work that has been previously done across the years of the MRI tumor detection. So without any further ado, let's dive into the topic. So for the contents, we're going to go through the abstract, then onto the literature survey, and we further explore what is the problem, and then what solution that we have devised, and then the results and the conclusion. So to put it short, the abstract, first thing is the tumors that occur in humans as well as in various different organisms. So tumors are being one of the deadliest diseases that occur for the cancer and different other diseases as the previous stages. So for detection of these tumors, we only have two kinds of scanning available. So one is the MRI scanning, which is also known as magnetic resonance imaging, and also computed tomography. So both of these need a substantial amount of radiation that is being exposed through the host. So which will, in a longer period, will lower the health of the host that is being suffering with these tumors. So for these overdue, we can use the scans that have been previously scanned and maybe simulate these subsequent scans through MRIs and convolution neural networks. So moving on to the literature survey, we have been taken pieces of the literature survey that has been happening with various different departments of tumors that are being going on. And we are trying to make a scalable architecture using federated learning where different medical institutions can come together and share their analysis of tumors with the patients that they have overseen throughout the years. So these are all the 5 types of papers that we have gone through. So first paper is regarding the tumors, and second is also regarding the tumors, but with different kinds of methodology. Second is the GANs, which is generative adversarial networks, which is also known for their capability of image generation, that is synthetic dataset scans. And third, and the fourth most, is the federated learning that we already have in the scalable architecture that we are trying to implement right now. And next is the K-image mixing, which will be also a part of federated filter that we are trying to implement. So moving on to the existing system, the existing systems that are already present are kinds of pieces. So they are not together. So we are trying to bring all those existing systems together. So let's go through one by one. So the first existing system that we have is deep learning models. As we already know, they are used for every other task right now in nowadays. Next, we have image mixing implementations. So these image mixing implementations that we have already discussed in the past slide, that is K-image mixing, is used for training models which have limited amount of data. Next is GAN-based architecture. So GAN is basically a neural network that is connected with a zero-sum game. So we have a generator and a discriminator that tries to run on a zero-sum game and try to generate synthetic data of it. So this is used for generating more amount of samples when we are on a limited amount of data. And federated learning, as we already discussed, is a kind of method that enables us decentralized learning without knowing the details of the host. So here we are using federated learning to hide the privacy information of the patient. So moving on to the limitations of existing system. First is due to limited amount of data, we have overfitting issues. And next, these all kinds of systems have lack of robustness. So they are not applicable for different kinds of tumors. They are only designed for a single tumor type. Next, we have outdated data handling because due to very limited amount of data, we don't have yearly or monthly updates coming up for the newer cases. Next is the resource intensity. To train these models, we need higher amount of GPUs because they have image preprocessing built into it. And next is absence of future-proof models. As we already discussed that there is a lack of data, so these data will be outdated for a future reference. So the proposed system that we're trying to build is requiring minimal amount of hardware. Next, it focuses on necessary details that are only focused upon the tumor types. Next is a robust architect design that will be adaptable for different types of scenarios for different tumors. And next, we are trying to promote the data privacy and decentralization. So the advantages of proposed is first, we are trying to augment different kinds of scenarios from limited amount of data. Next, we are trying to efficiently pre-process the image so that we can take what are all the details that are required from a very minimal image that we have. Next is the scalability and privacy, as we have already discussed for the federated learning, which enables us the decentralized training along with the scalability. Next, we have privacy-focused feature sharing. So the hosts in the federated learning will only share necessary features, hiding the privacy-related features within themselves. Next, we have enhanced model architecture. So we are trying to employ very bigger architectures like ResNet and UNit, which will have lot of number of layers that will try to retain most number of features of the images. So moving on to the problem statement. So for coming on to the abstract, we need a robust architecture, which is data privacy and data sharing centric and also scalable, and it should be future proof. So dataset descriptions. So all of the datasets that we are taken are from challenge datasets. So for the context that I want to put in, the challenge datasets are the datasets which happen as a part of a challenge that takes place in the medical industry to like simulate what are all the possible enhancements that they have done every year. So we have taken those high quality image datasets from each of the challenges that will happen throughout the year. So you can see the different types of challenges over here for different types of tumors or different types of organs. So moving on, we have methodology, which will be taken over by Jan, my co-author.
Hello everyone, this is Jan. So from here we are going to start from pre-processing steps. where we are going to first focus on standardization, where we are going to resize and normalize the images, remove the noise, and enhance the contrast for better clarity. Then we are going to focus on color transformation, where we are going to convert the images to different color spaces to improve the segmentation part. Then we are going to focus on color thresholding, which highlights the tumor area based on pixel intensity. Then we are going to do morphological operations, like we are going to clean and shape the tumor regions, etc. So then we are going to do some ROI extraction, like detect the tumor boundaries and extract only the tumor area. Then we are going to visualize the output. So here we have data argumentations using GANs. So we have CGAN. So I mean, we have tried this different kind of GAN argumentation. So we are going to select the best one out of it. So we have tried CGAN, which generates the tumor images based on class labels for controlled output. So we have conventional GAN. So we use convolution layers to create clear and realistic MRI tumor images. And we have style GAN, where we are going to add some filters of each and every style of, each and every variations to generate diverse and high resolution MRI scans. Then we have WGAN, which ensure the stable training and better image quality. So we have some tumor detection models. So we have used for brain tumor model, we have used exceptional model with custom four class classification. Like it detects all kind of tumors which are related to brain and use early stopping and validation monitor for better performance. Then we have lung tumor model, which uses VGG16 with custom dense layers for feature extraction, trained on LIDC and LIDC dataset, and optimized with categorical cross entropy. Then we have breast tumor model, which is built with customized CNN using multiple convolution and pooling layers. So this is our flowchart where we are first going to do some data collection and we are going to gather all the MRI images and we are going to segregate the data. Then we are going to follow the pre-processing steps as we have discussed previously. And then we are going to normalize the images, grayscaling and image enhancement, and which helps to improve the accuracy of our model. And we are going to do some noise reduction and sharpening.
This is a gentle reminder that 9 minutes have been completed.
Sorry?
This is a gentle reminder that 9 minutes have been completed.
Yeah, these have been completed.
I'm talking about the time, sir. 9 minutes have been completed. Only 1 minute is left.
Okay. Sorry, sir. Okay. So for data argumentation, we are going to do some argumentation with our models which we have discussed, and then we are going to extract the tumors. Next. So here, this is our training architecture where we are going to start the training process and we are going to send the images to the particular model. And this is our deployment architecture where we have a whole CI/CD pipeline and the MLOps for our deployment. So these are the results, and this is our accuracy for brain, lung, and breast tumors. Yeah, these are the results. So from here on, my co-author is going to continue.
So as we already discussed, so we are trying to get whatever the scalability that we already have, and we are trying to implement explainable AI, which will guide the host to like get what are all the scans are implementing right now.
So
And
you have
for the
exceeded the 10-minute time limit. Kindly conclude the presentation.
yeah, so for the conclusion, with the WGAN will be used for like generating very much synthetic data, and also all these VNN and VGG16 will give a over priority for training the images, and also we have flexibility and operationability with strong scalability with the federated learning. These are all the references that we have been using for our project. So thanks for the authors, and thank you.
Okay, I have one question that how you validate your data, because it's a GAN you are used, right? You have created the synthetic data using
Yeah.
the GAN. So
Yeah.
how you validate your work?
Yes, ma'am. So we have a custom return validator for the algorithm that we are trying to use. So that as I've already spoken about WGAN, So WGAN has a Versatarian distance. So using that distance formula, we are trying to validate the kind of image generation that we are generating through the GAN.
And how does your federated learning preserve this patient data privacy?
So each and every institution in the federated network will have their own custom filters implemented. So for example, let's just say we have a patient data that has to be masked and to be sent through the central server. So these institutions will have their own custom built filters that will block the data of the patient, and then only the related information will be sent to the server for processing.
Okay. 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 For now, good.
Yeah, thank you.
Thank you for your presentation, sir.
Yeah,
Now
thank you.
moving on to our next presenter. Next, I would like to call upon Sir Amol More to present his paper on the title Evaluating Heat Transfer in Various Heat Sink Designs under Control Experimental Condition. Do we have you here with us, sir?
Yes, sir, I am there.
Okay.
So my screen is visible.
Yes, sir, your screen is visible.
So good morning all. I am Mr. Amol More from AISSMS Institute of Information Technology, Pune. My paper ID 513, evaluating the heat transfer in various heat sink design under controlled examination experimental conditions. So this is the outline of my topic of the presentation: introduction, background, research objective, methodology, result and conclusion. So moving ahead, in modern electronics, the compact electronics are compact electronic devices are coming. So, and due to that, the compact electronics increasing the power and decreasing the size, they have high heat concentration and excess heat in the due to so the same high heat releases the hardware damage and reduce the reliability. And the same time, the lifespan of the equipments or the devices are reduced. So for that, the thermal management is required. So thermal management is required in applications like smartphone, laptops, GPU servers, or the central processing units. So the performance is optimized based on the various factors, and those various factors are like material of the heatsink, then fluid, and the optimization of the same. So based on that, we have to integrate the heatsink by using various parameters. First of all, we need to understand what is the heatsink. So heatsink is the component which is dissipate heat away from the heat generating equipment like processor, LED, or electronic components. So to ensure the proper thermal management in the electronic system, so we should have the proper heat dissipation and prevent overheating of the electronic components. So that there will be a performance reliability and life of the particular electronic components will be increased. Also, we should ensure that irrespective of what overloading conditions or the power and the compact size, there should not be overheating issue in the electronic components or the compact electronic circuits. So we have to optimize the temperature and minimize the temperature in the electronic components. So this is the actual or traditional heatsink we can see on the left side of the same. And now we are going to study focus on proper the main cause of the failure of the cooling or thermal management system in the electronic device, like heatsink material, heatsink geometry, and the maintenance location and the service. Same time, the which fluid we use in the same. So on the right side, we can understand the major cause by various researcher. The 55% contribute the temperature percentage or the temperature is that is overheating issue in the heatsink, which causes 55%, and failure of the heatsink is observed. So objective of this presentation or the study is to examine different heatsink types and handle it under various heat load conditions and airflow. So we have to investigate the improvement by using the copper material, perforation integration, or the by using phase change material. And the same time, we have to consider the above parameters like heatsink material, geometrical parameters, and the composite things and the optimization of the thing to find out the good thermal efficiency. So these are the summary we can see by the different researchers are found. So with respect to the material geometry, heat flow condition, composite heat sink, they have find out some results. So uh, we can find that in this particular chart, the copper heat sink is having better high thermal heat reflux than other. So 25% the fin heat sink with the copper material which shows, and the spiral heat sink which shows the 15%, and composite heat sink which improved uh, improved thing we can see in the same, sorry. Hello, is my screen visible?
Yes, sir. Your screen is visible.
Yes.
What? So in the picture we can see the heat sink, and in the experimental conditions we have decided to go with the wind tunnel, horizontal wind tunnel, and in horizontal wind tunnel the parameter selected for the fluid as a normal air, environmental air, and which suits the heat loads, the 10 watt, 20 watt, and 30 watt, and the ambient condition which is considered to be get a constant and the good result, the 25 degrees Celsius the ambient temperature. The in the experimental setup we can find out the variable blower or the speed fan is used inside the heat sink is used, and we have measured the temperature, pressure, velocity, and the fluid flow visualization with by using the data acquisition system. So these are the on the right side we can see the actual setup which measures the performance, the velocity, temperature, and the pressure of the heat sink, and based on that we can find out the heat transfer rate, temperature distribution, and these are the various heat sinks which modeled in the CAD model. So pin heat sink, polar heat sink, perforated heat sink, and the PCM heat sink. So this is the analytical model which is used the traditionally plate fin heat sink to find out the fin heat transfer rate, fin efficiency, total heat transfer rate of the total fin heat sink, and the thermal resistance. Same to calculate the performance factor of the heat design, we have used these correlations, and modified thermal conductivity. We focus on the thermal conductivity or hybrid aluminum heat sink, which is a new for in our research. So we can find out the thermal conductivity effectiveness or the overall heat transfer rate by using Newton's laws of cooling. These are the cases, the 5 cases I used in the my research. The total 5 heat sink with the base 60 by 60, and the base thickness for all 5 to 6 mm, and fin height was 30 mm, and the diameter 5 mm. So by 6 by 6 array we have used based on the optimization parameter to find out the performance. Same time the modified conversion we have seen the copper mud insert, we have used the perforated fin and the phase change material as a paraffin wax we are used to find out the performance of the heat sinks. So looking at the result, we can find out in the left side the heat sink performance, the actual temperature, the minimum temperature or the normal and environmental temperature 38, which gives PCM that is phase change material fin heat sink 38 degrees Celsius for 30 watt, that is the maximum wattage, which itself indicates that the minimum temperature will be observed in the phase change material fin heat sink, and the plain traditional pin fin heatsink or the plate fin heatsink for 25 at 45 degrees Celsius. And these are the graphs we can show when the length of the fin increases, the efficiency is reducing. So in the again comparison with the different plane fit performance based temperature performance, we can find that in the graph with respect to the different plate fin heatsink and the average base temperature of the heatsink, the PCM is over uh, means outstanding performance, which gives the 38 degrees Celsius for all the conditions. Again, the same thing, we can find out the heat dissipation rate with respect to the different heat sink. So again, the plate fin heat sink is reducing or removing minimum heat sink, whereas the plate fin PCM pin fin heat sink, that is a phase change material paraffin wicks, which dissipating heat from the devices the maximum, and the moderate is perforated. Similar way, on another side, we can find out the heat dissipation rate and the base temperature. Again, the phase change material heat sink is given a good results. So based on this, I can conclude that phase change material with the fin heat sink with the optimized condition 6 by 6 fin array and 30 height heat sink, which gives the good result comparative to the other results and the geometrical picture with the combination of the copper material and the pin fin heat sink. So recommendation for the next research, phase change material with the fin fin heat sink with the perforation of copper material, so can be recommendation for high performance and thermal demanding systems. So next future scope for this is to have a CFD integration with the real-time sensor data, and then hybrid material can be used, graphene as a hybrid material can be used, and then optimization, design of optimization using machine learning algorithms. So this was my presentation. Thank you. These are the references which I have used for my research. Thank you. I would like to thank organizing team and session chair ma'am. Thank you.
Yeah, very good research work, sir. Your work is very nice. Uh, Actually, there is no as such questions for me to ask you, but just a curiosity I asked you that
Yes, ma'am.
how do the surface enhancement affect that radiation and convention heat transfer in
Uh,
heat
m-
sink?
Major parameter is, madam, surface enhancement only. The
Okay.
surface area, more the surface area, more the
Hmm.
heat transfer rate increase. In our case, the
Hmm.
perforation and the copper heat fin heat sink. With the copper insert, we increase the heat transfer area. Um,
Hmm.
and the same optimization parameter based on the research paper G. Maveti, we have used the same, and we find out that as the surface area is increased, we find this heat transfer augmentation or the increased heat transfer
So
rate.
that surface enhancement, roughness and coatings, all these things are covered, right?
Yes, yes, yes. Surface
Okay.
enhancement. Okay,
Hmm.
and this manufacturing processes are different. If I go for the casting, the less no, heat transfer enhancement I will found. If I go with the CNC, it will go with we can find the good thermal heat transfer enhancement.
Okay. Okay. Very good, sir. Very good. Okay.
Okay,
Thank you, sir.
thank you, ma'am.
Thank you for your presentation, sir. Now moving on to the next presenter. Now I would like to call upon Sir Ainamputti Sivaramaraju to present his paper on the title Evaluating Lexicon-Based and Transformer-Based Approaches for Sentiment Analysis in Amazon Fine Food Reviews. Do we have you here with us, sir?
Yeah, I'm here. Can I share my screen?
Sure, sir. But actually, you're not audible. You're mute right.
Good morning, all. I am Sivaram Raju, and I feel privileged to present our research titled Evaluating Linux-based and Transformer-based Approaches for Sentiment Analysis in Amazon Fine Foods. And
Okay.
this work was conducted under guidance of Dr. Sunita ma'am and my co-authors Nikhil, Jahnavi, and Varshit. And moving on next, these are our contents, problem statement, tools and technologies, architecture, model, and dataset, formulas, and codes, results, and conclusion. And coming to problem statement, in the digital era of e-commerce, platforms are thriving with customers heavily relying on customer product before making purchases. However, when thousands of reviews are generated daily and analyzing them manually is impractical, business need an automation system to effectively understand customer sentiment for enhancing products, services, and marketing strategies. Our research aims to solve this by leveraging uh, natural language processing NLP. We focus on two popular but fundamental and different sentiment analysis techniques. And Linux based, we used VADAR, which uses predefined sentiment scores for words. And transformer based, we used Robota technique, which learns deep context meaning from the data. The objective is to evaluate how each performs in real world scenarios and perform insights on accuracy versus efficiency trade offs for business. And tools and technology, we choose Python for simplicity and rich NLP libraries, and NKL natural language toolkit. We have used it for text processing, tokenization, and sentiment analysis with VADA. And VADA, we basically use it for comparing with Robota. And pandas and numpys are used for handling pre-processing and analyzing structured review data. And matplotlib and seaborn are used for data visualization libraries for presenting sentiment distribution and insights. And widely used for evaluating machine learning techniques through matrices like accuracy, precision, recall, and F1 score. And we have, for time being, we imported a data set from Kaggle. And first, I would like to speak about our architecture. Basically, in full-fledged, we would like to start from data scraping, from importing the data from any one of the UPI, but we could not get the data, so we have taken the data set from Kaggle and we performed some data cleaning and data pre-processing techniques, and we have cleaned the data. and next, sentiment analysis, two models were applied. VADAT provided quick but rule-based analysis scores, and Robota performed the data through contextual embeddings. And this is the sample data set which we have imported from Kaggle. The top 30, we have first tried to do the analysis on 30 reviews. Let's dive into the model. VADA works on predefined sentiment lexicon. Each word has a po- uh, polarity score. VADA sums up sum these to classify the sentiment. It is fast and explainable and works well for short texts. However, it struggles with context and n- uh, navigations. Robota, on other hand, is based on transformer architecture. It uses self-attention mechanism and learns deep contextual relationship between the words. It is pre-trained on massive datasets and fine-tuned on sentiment data. Robota excels in understanding complex patterns and like double meaning and double negative words. Nowadays, most of the customers are using will if they are unsatisfied with the product, some might be using like idioms, etc., and they would like to scape up the meaning. I mean, the normal meaning will be different if we understand in the form of dictionary way, but their feelings will be different. If for VADA will be taking it as positive review, and Robota can identify it and classify it as a negative review. Next, coming to our data set and formulas. For counting the reviews, we have used set X label so that we can classify our reviews. We have taken out of 100, out of 1,000 reviews, almost everyone used to give it as a 5-star review for the product. And the fine food attributes of our dataset are text, user ID, product ID, rating, and summary. And pre-processing we have done in tokenization, splitting text into words, and normalization, lowering the case and removing punctuation, and sentiment score applied through VADAR formulas and Robota embedding. And we developed our solution entirely in Python. For VADAR, we used a sentiment integrator analyzer from NLP, which provides scores for reviews in positive, neutral, negative, or a compound score. Compound score, if the review is positive, it will be calculated as extreme positive, and if the review is negative, then it will give the extreme negative value. For Robota, we use a transformer library from Hugging Face. This model provides tokenized reviews and output possibilities for each sentiment class. Both models were evaluated using libraries like skitlearn from matrices, ensuring a fair comparison. And how we calculated accuracy using first for sample data set, we calculated the accuracy by correct predictions by total predictions. And for complete data set, we used configuration matrix for comparing the accuracy. And the accuracy of VADAR is around 84%, and the accuracy for Robota is around 90%. And coming to our results, if the review is 5-star, we have classified it as violet, and if it is 4, then it is red, and if it is 3-star, it is green, and yellow. If it is 2-star, it is yellow, and 1 is blue. VADAR typically, some reviews you can see the negative reviews are rated 5 by VADAR, but in the same case, Robota used to classify them as used to give the correct review. And coming to conclusion, VADAR is suitable for quick and low resource applications like dashboards and real-time monitoring. Robota is ideal for scenarios where accuracy matters more, and like detailed market analysis or legal reviews. Our study choosing the right tool based on the project needs. Both models have their place in industry applications based on whether speed or depth is prioritized. Future work would include hybrid approaches, combining both lexical based with transformer deep. And thank you all.
Good, very good presentation. I have few questions related to the sentiment analysis.
Okay, ma'am.
How your model performance vary across different sentiment classes? And also one more is missing things, that is how the method handle this class imbalance in your presentation.
Uh,
Can you just explain me?
okay, ma'am, you mean different classes means different types of scenarios and different
Yeah,
for
yeah, you
different
have
products.
correct.
Yeah,
Some kind of negative, neutral, positive might be the classes will be there.
yeah.
So how it is handled?
Ma'am, it basically VADAR understands the meaning of the words and it will give a score for each and every word. And it will consider based on the rating, based on the total rating. It will be considered, for example, if some positive word is there, it will be giving some score for the positive word. And if a negative word is included in the review itself, it will give score for negative word itself. And the total overall calculated score might be in, if it is in the negative, then it will classify the review as negative. If the overall score is positive, then it will classify the score I mean the review as positive.
Okay. Okay. So it's already implemented and you got the results, right?
Yeah, ma'am, it's
Yeah.
already implemented.
Okay. Is there any fine tuning or something like is required?
Yeah, ma'am. Basically, our future advancement is we would like to classify I mean, the real reviews and the fake reviews. First, after classifying it, then we would like to implement these mechanisms.
Okay. Okay, good.
Okay, ma'am.
Yeah.
Thank you.
Thank you for your presentation, sir. Now moving on to our next presenter. I would like to call upon Ma'am Ruby S. Chanda to present her paper on the title Sentiment Analysis of Financial Trades and News Using Machine Learning to Identify Trading Opportunities. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Sir Anjane K to present his paper on the title The Role of Social Media Information Sharing on Generation Z's Green Purchase Intention. Do we have you here with us, sir?
Hello, am I audible?
Yes, sir, you're audible.
Just share my screen.
Sure, sir.
Is it visible now?
Yes, sir.
So shall I start?
Yes, sir.
So good morning, everyone. I am Anjaneya, representing Amritsar School of Business Kochi, along with my co-authors Anjaneya P and Samira S. I am thrilled to present our research paper that explores a timely and important question: how social media shapes the green buying behavior of Gen Z. And the topic is the role of social media information sharing in shaping Generation Z's green purchase intention. So, in a world grappling with climate change and rising environmental concerns, Gen Z born between 1997 and 2012 really stand out. They are socially aware, digitally native, and willing to support brands that care for the planet.
So
So,
your
our
voice is
study.
not so your voice is not
Hello?
audible properly.
Hello?
So your voice is not audible properly. There's some disturbance from your side.
Yeah, is it audible now?
Yes, sir.
Yeah. So, our study asks, can social media information sharing actually influence the eco-conscious generation to make sustainable purchase decisions? So we focused on three objectives. First, to examine how social media information sharing affects green purchase intention. Second, to see if this relationship is mediated by two internal factors: perceived green value and subjective norms. And third, to test if occupation plays any role in this relationship. So our objectives are to examine the impact of social media information sharing on Gen Z green purchase intentions, analyze the mediating role of the two variables, assess the moderating effect of occupation. So the theoretical framework. So we built our study on the stimulus organism response model. Here the stimulus is social media content related to sustainability, like eco tips on Instagram or green lifestyle reels on YouTube. The organism represents internal factors, our mindset, values, and peer pressure. And the response is the intent to buy eco friendly products. So the relevance of this research is that growing importance of sustainability in India. We know about various government initiatives like Swachh Bharat Abhiyan, plastic waste management, etc. And all these are influencing the social media consumer behavior. So Gen Z in India is highly engaged on Instagram, YouTube, WhatsApp, and all other social media. So the social media information sharing plays a crucial role in educating and persuading young consumers about green products. So most prior research has focused on Western market. This study provides an India-specific perspective on how digital engagement translates into sustainable purchasing. So, so this are the literature review we had conducted, and one is based in China, and one is based in the US. So this is the hypothesis. So we have the 8th hypothesis. So we can see how the social media information sharing, it shows it is connected to the subjective norms and the perceived green value along with the green purchase intention, and while the occupation also gives a proper enhance to contribute to the green purchase intention. So the methodology. So we used a quantitative cross-section approach, collecting data through online surveys from 222 Gen Z participants. So 75% were students and 25% were working professionals. We used a 5-point Likert scale to measure agreement levels, and we analyzed the data using regression, SEM, and mediation moderation techniques. So the 5-point Likert scale, as you know, is 1 strongly disagree and 5 strongly agree. The independent variable was social media information sharing. The dependent variable is the green purchase intention. Mediating and moderating variable as perceived green value, subjective norms, and occupation. So this is the analysis. We have found the mean and the correlation for the variables as in the slide. The scatter plot and the social media information sharing versus GPI shows positive correlation and links. So we found that social media does significantly influence green purchase intention, especially through platforms like Instagram and YouTube. Secondly, the effect is strongly mediated by both perceived green values and subjective norms, meaning that the more Gen Z values as products eco attributes and the more they feel the social pressure, the likely they are to buy green. Third, occupation matters. Working professionals are more influenced by peer norms compared to the students. So the interpretation, like I said before, there is strong and consistent intention among Gen Z to purchase green products, strictly a positive behavioral trend driven by social media and perceived value. So to conclude, I would like to say that this effect is indirectly mediated by perceived green value, subjective norms, fostering eco-conscious attitudes and social behavior. And occupation also provides a strong influence on the social norms on green purchase intentions compared to students. Thank you.
Very good. It's actually innovative topics you have picked, and it's a problem you have solved. Very good. That's good.
Thank you, ma'am.
Yeah. So few questions, as you have collected real-time data, as you shown that you have collect from Instagram, WhatsApp, and others platform, social media. So the basic questions that how does the frequency or type of this green content shared on any of the media, social media platform, that Gen Z purchase their intention towards sustainability products? What is the frequency?
So the frequency depends about the like for average Gen Z they generally spend about 45 to 90 minutes on social media on a day. And so the type of green content that should be visible is about 5 to 15 times a day. So it could be stories, could be reels, could be shorts or small ads also. So it's about 5 to 10. because we need to capture the attention span, because of reels and all, our attention span is going down. So we need short form contents like reels and shorts and all to capture the market eye of the user.
Okay. Also from your study, can you just explain me in which platform or specific features, or like any features like story or reel or likes and share, most effectively enhance this green purchase intention among these Gen Z users?
So basically, using the Gen Z, it would be Instagram, because it is the king of influence, and the YouTube is a trust builder. So Instagram is having lots of reels and stories. So we see a lot of just one click you have of an eco-friendly product. The ads corresponding would be coming like eco-friendly products, eco-friendly toothbrush, eco-friendly clothing, eco-friendly buy EV, etc. So reels would be the most relevant for our generation. And corresponding to the other application, that is YouTube, it is also shorts.
Okay. Okay, good.
Thank you.
Before moving on to the next presenter, Sir Darshan LM has raised his hand. Sir, could you please unmute yourself and ask it out? So your voice is not audible. Moving on to the next presenter.
I think he has some problem.
Yes, ma'am. Yes.
Darshan.
Yeah.
You can put your questions or doubt in this chat box, if possible, Darshan.
He told me to go ahead. So moving on to the next
Okay.
presenter. Next, I would like to call upon Sir Mustafa Limidiyawala to present his paper on the title AI-driven disaster prediction, integrating earthquake and flood forecasting for enhanced resilience. Do we have you here with us, sir?
Yes, sir. And my voice is visible, audible?
Yes, sir. Your voice is audible.
Yes, I will present it. My screen is present.
Yes, sir. Your screen is visible.
So our topic is AI-driven disaster prediction, integrating earthquake and flood forecasting for enhanced resilience. Paper ID 453. So this is a table content, introduction, problem statement, all. So introduction, artificial intelligence increasing playing a crucial role in disaster management by enhancing the efficiency, effectiveness of disaster relief coordination. AI technologies such as machine learning, data analytics, and robotics are utilized to predict disaster, to optimize the resource allocation and communication among the agencies. So we are predicting the disaster for the earthquake and flood. So main our problem statement is natural disasters such as earthquakes, flood, and tsunamis cause devastating impact to human life. As we see, as the earthquake comes that cause devastating disasters, infrastructure and economy's timely prediction and efficient resource allocation are critical to mitigating these effects and ensuring quick, effective responses. So challenges faced like likely of timely, accurate disaster prediction, inefficient resource coordination, and difficult in predicting secondary disaster like tsunami. So our main objective is to develop disaster prediction relief site that predicts the natural earthquake and tsunami and dynamically manages the relief for the disaster as To integrate integrating random forest and gradient boosting machine learning models for earthquake, flood, and tsunami prediction to visualize these disaster-prone zones using geospatial mapping to allocate relief resource based on the predictive severity on the disasters. These are the literature surveys. All we research about this paper. So moving on to block diagram. So first we have taken the input data, and then we have taken on the input data we are getting the real-time seismic activity rainfall data and meteorological all data. On this model, we are predicting prediction models, random forest for prediction and gradient boosting for the flood prediction, and we are getting the output. And then we are calculating the magnitude and severity, and based on that, we are doing the geopolitical real-time updates and disaster zone using Leaf.js for showing the map. And we are doing the resource allocation based on the severity, like how much the magnitude is there, like 7 point and is the high magnitude. So we are allocating the resources to the like how much resources is needed for it. And if the execution fail, it will repeat it. So this is the architectural diagram. So in this phase, we are taking the input layer, collecting seismic weather and oceanographic data, and then we are doing the processing layer using random forest and gradient boosting for the prediction. Visualization layer displays the disaster prediction on geospatial map, and then doing the resource management layer dynamically allocate the relief resources based on the severity. So the technology used is random forest gradient boosting, and for mapping Leaf.js and Google Map APIs. For backend, we have used Python and Flask, and for database, we have used Kaggle for storing historical and real-time data. So methodology is that for the first, we have collected a data collection like real-time data for earthquake, flood, and tsunami. Then you predict the model, use to train the model, random forest and gradient boosting for earthquake and tsunami. Then prediction generating real-time disaster prediction, magnitude and severity. And then use Leaf.js to visualize disaster prone zone and severity levels. And relief resource allocation, allocate resource like medkits, shelters, and food based on the prediction severity. Is the random forest ensembling learning method using decision tree, input seismic data, magnitude, depth, and location, output, earthquake prediction. And for the gradient boosting for flood prediction, regression technique that build weak learners sequentially. Input rainfall data, river levels, and output flood risk predictions. And we have achieved accuracy for the random forest 85% and gradient boosting for the 90% accuracy and geospatial map visualization disaster prone zone and real time updates based on the new data inputs. So this is the conclusion. The disaster prediction and the real relief dashboard successfully integrate machine learning for disaster forecasting with real-time geospatial map and resource management. And the system can predict earthquake, flood, tsunamis, helping authorities to take proactive measures and the integrating predictive models with relief system, ensuring timely resource allocation and improved disaster preparedness. So the limitation is the data quality. The system accuracy depend on the quality and availability of historical and real-time data. Model limitation, predictive models may have limitation in forecasting unpredictable data. Data integration, the accuracy of geospatial depend on the precision of mapping tools and data. So the future scope is expansion to the other disaster, include prediction to the hurricane, wildfires, and other natural data, integrating with IoT and mobile app integrations. So this is other references. Thank you.
Okay. So, the challenges are there in your topic. How you collect your data set? How you
Yes,
validate your
ma'am.
data?
And we have collected data from the Kaggle.
Hmm.
Then we have trained the model on that. Use the random forest for
No.
the.
How you validate your complete work? That is my question actually. Dataset, I know that you have used in the Kaggle dataset, but how you validate your work?
And firstly, we have taken the data, then we have predict the model. Based on that, we have used the leaf.js for the mapping, plotting the, and we also use the USGS map, which is I have high accuracy.
That's fine. That's fine. Okay. Okay. Fine now. What novelty is in work? You have used all the pre-trained models, but what is the novel things or any approach you apply on the data set to get the accuracy?
Yes, ma'am, we have applied. We have get the like first we are getting the uh, magnitude, depth, longitude, and longitude for the accuracy for training the models.
Which models you apply? Deep learning models?
No, ma'am, we have applied. We have used random forest and gradient boosting. For random forest, we have used for earthquake, and for gradient boosting, we have used for floods.
How many records are there? Means the data set size?
Records, ma'am, we have records. We have taken the data from Kaggle. Like we have taken that, and we also use USGS for the
So
data.
have just to understand the data first. That is my basic question. Have you understand the data?
Yes, yes,
What is the
yes,
size? What is the volume of that data? Okay, what key parameters are there? Have done your study?
yes, ma'am.
Okay. So, is there any hybrid model you have applied?
No, ma'am.
Means combining the deep learning model with the machine learning model so that we will get the accuracy.
No, ma'am. We have used only machine learning models for predicting the accuracy.
Okay, okay. Okay, you can leave. Good.
Okay, thank you.
Thank you for your presentation, sir. Now moving on to our next presenter. Next, I would like to call upon Sir NSSS Aditya to present this paper on the title Developing a CNN Model, Rebecca, for Effective Lung Cancer Classification on Histopathology Images. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next upon, I would like to call Ma'am Rubias Chanda to present a paper on the title Enhancing Customer Experience with Generative AI-Based Net Promoter Score Prediction. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next upon, I would like to call again Ma'am Rubias Chanda to present her paper on the title Sentiment Analysis of Financial Tweets and News Using Machine Learning to Identify Trading Opportunities. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll move forward with the session. I sincerely thank our authors for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support in this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificate through email within 2 working days. Further, all the viewers all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also thank our session chair, Dr. Disha Swankare, for sharing this session. I would now like to request ma'am to share her thoughts and feedback about the presentation for the session.
Yes, definitely. Actually, yes, it's a great opportunity. So, as a session chair for engaging this insightful technical session, actually, yes, I would like to heartfelt thanks to organizer for inviting me and putting together such a platform, okay, in this online and innovative collaboration in this academic things. Yes, I am very much happy about today's presented papers, which is demonstrate a remarkable cutting edge research actually. Some practical application was there. Some researcher has explained practically also. Some interdisciplinary insights was there. So definitely, it's things which is going towards the sustainability in intelligence future. Some of the topics are related to mental health, some child related, autism related, some topic was there. One of the topic is Gen Z, which is very trending actually. We requires these things as a innovation in that field. So definitely today's session was particularly diversified session actually in all the domain and all the aspects was covered. So thanks all the participants for doing their research in their field. Definitely, it's research must go on. So continue with this conference. I encourage all the participants to further just uh, things are required for collaborative opportunity. Thank you very much. Thank you all.
Thank you, ma'am. Here's a token of appreciation to the chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. Thank you, ma'am.
Thank you.
Just before we start end the session, I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe. Take care.